into just kind of a brief topic within topic 5.2, which is how to measure pollution. The reason we're doing this today is next class we're going to talk about eutrophication, which is directly connected to something called a measurement called BOD. BOD stands for biochemical oxygen demand, and what it is a measurement for how much organic matter is in a water sample. So let's see. It's an indirect measure. For organic pollutants. And if you're thinking to yourself, what the heck is an organic pollutant? I have a few examples for you. The first one from the textbook that I have is pulp from a paper mill. So you can imagine breaking down all those trees and all you get this nice, beautiful white paper. Where does the rest of the tree go? There's waste from water treatment plants. There's waste from feedlots, so feeding our meat that we love to eat. There's waste from food processing plants. Let me scroll this down a little bit. There is waste from failing septic systems. So if you're not hooked up to the county waste management program, you have your own septic system. And then there's something called, let me see, cattle slurry. So I actually had to look this one up to figure out what it was. So I'll come back to this page, I promise, but I'm going to go to another page for you so you can see what it is. So essentially, when you're raising large amounts of cows, like this guy, instead of putting them on nice soft hay, they put them over crates. So all that waste just kind of falls down. So it could be, what's in there is not just manure, and it's feces, it's urine, it's dead skin from the cows. Whatever comes off the cow kind of gets washed away in this crate. And when I learned what this was, this is pretty much how I felt about it. Just kind of scared. It's all the gross stuff from a cow. And I thought that it's just really gross when I learned what it was. So I'll go back to the notes, and I apologize. I needed to have that little break to figure out what the heck cattle slurry was. I'm going to extend this page a little bit. And then, of course, we have runoff from stormwater. Our BOD is measured in milligrams of dissolved oxygen. Which I'm going to go ahead and call DO, over liters. So if we were to go back and let's take a look at some of our examples, for the amount of BOD, I apologize for, let's take a look, wastewater treatment plants, for treated sewage, it's about 20 to 60, so it needs that much oxygen. The amount of BOD for cattle slurry is 10,000. Okay? So there's a really, really big difference. So what the heck is BOD? What is it actually? It's the amount of oxygen that microbes need to break down whatever organic material is in there. So if we're looking at our cattle slurry, it needs 10,000 milligrams of dissolved oxygen to break down the amount of sewage that's in 1 liter, while in unpolluted water it's typically less than 5. So to understand, we kind of want to do what a BOD is. It's the amount of oxygen needed, and it's directly correlated, as you can imagine, to the amount of dissolved oxygen that's in a water sample. So I was looking around and I was asking people for the best way to explain this. And the best ways to think about it is in terms of money, essentially. So let's talk about the bills I get at the beginning of the month. So this is the first of the month, let's say. So the demand on my money at the first of the month, it starts off, I get rent, and then I have to pay my electric bill, and then I have to pay my credit card bill. So there's a high demand for the amount of money I have. But near the end of the month, I don't have as many bills because most of my bills come at the same time, and the demand gets lower. Now, say we're talking about the amount of money I have. All right, so this is how much money I have. So I just got paid, so I'm pretty happy, but then all of a sudden I have to pay my rent bill, so I don't have as much money left. Then I have to pay my electric bill, then I have to pay my credit card bill. But once those go and I start to get paid again, I get paid the second week, then I can build my money back. So they have a very close relationship. So if this guy is my amount of dissolved oxygen, and this guy is my biochemical demand on oxygen, which is my BOD, my biochemical oxygen demand, when I need more to break stuff down, I don't have nearly as much dissolved oxygen. And we're going to be talking about these two, when we're talking about eutrophication, which is our notes for Monday. So you can actually use this as a way to measure water quality. And let's keep going and talk about how do we actually measure BOD? What is the science behind it? And I'm going to scroll down. How to measure. So what I need to do is I need to have my little water sample. I need to take 2 samples from here. The first one I'm going to take is my first sample. What I'm going to do is I'm going to put it in a 1 liter bottle that is covered in black. The reason for this is we don't want photosynthesis, so no light needs to get through. Because if we have photosynthesis going on, we have an increase in oxygen. And I'm going to take my dissolved oxygen sample right away. So what that's going to give me is the initial amount of oxygen present. Let's do purple. My second sample, we got them on the same day. What I want to see is how long it takes to break down that, or how much oxygen is needed to break down that organic material that's in here. So say this guy is by a big farm that's got lots of plants on it, and it just rains. We want to measure how much organic matter is in there. I'm going to incubate this sample, same deal. So it's in a 1 liter bottle that's blacked out. And I'm going to incubate it. I want to keep it at about 20 degrees Celsius. If I double check, I think that's about 65 degrees Fahrenheit. And it's going to be incubating for 5 days. Days. Sorry about that, guys. And what this is measuring, and I'm going to write it out, I know I said it earlier, is the amount of O2 needed to break down the organic material. So after 5 days, let's say what I'm going to do is I'm going to take my initial sample. Oops, I went too fast. After 5 days, the next thing you need to do is measure the amount of dissolved oxygen. To finally calculate it, my BOD is going to equal my initial sample subtracted by my incubated sample. And that's the basic way to calculate it. But here's the problem. I'm going to change the screen. So if you need to pause it now to get what I wrote down, pause it. But here's the next screen I want to look at. If you have a very, very, very polluted sample, by the time you get to 5 days later, if the dissolved oxygen in the sample is 0, you have to change your experiment a little bit. So if it's still 0, if it's 0 at the end of 5 days, you still have organic material in your bottle. Oop, I spelled material wrong. So what you need to do in order to figure this out is you need to dilute your samples. And you're going to dilute them until after 5 days you have at least 2 milligrams of dissolved oxygen per liter. And that makes sure you're breaking down all of the organic material instead of just some of it. So if you do just some, you're not going to get these big numbers like the 10,000 we got for our cattle slurry, which I think is so gross. And you're going to have an underestimated value for the amount of dissolved oxygen and the amount of biochemical oxygen demand there is. And that's how you do it, what it is, and then here is if you have a high level of pollution. I used our textbook, but I also used these 2 sources right here, which I thought were really, really helpful. So if you want to know more about how to do it, what it looks like, and how to set a procedure like this up, I really, really like these 2 sources. What I'd like you guys to do next is I put it up on our IB community page, but here is the link for it if you want to copy and paste it right now. There is a 4-question quiz. that I would like you guys to take. It'll take about 30 seconds. Use your notes. And it's just to make sure you guys understood what we went through today. So here it is. I'll put it up on the high school website. It's also up on our community page already on the IB, on our IB community page for Google. But go ahead and take it real quick. And question 1 is your name. Please do not forget that. I can't give you credit if you don't put your name in. And enjoy the rest of your weekend.